The mechanical system of this experiment consists of a flexible steel beam pin-jointed at both ends to a rigid frame. The apparatus is equipped with a high-precision speed control of a DC motor up to 3,000 revolutions per minute. The motor is a combined DC motor with speed feedback to give accurate speed measurement and control. The motor speed in revolutions per minute is controlled through a speed control unit. The DC motor is supported at the midpoint of the beam. The motor rotates two unbalanced discs in the longitudinal plane of the beam. The force exerted by the unbalanced rotation of the discs causes them to vibrate. A mechanical damper is attached to the beam at the same position as the motor. The damper consists of two sliding metal plates which vibrate in a tube of oil. The plates have holes that can be aligned to adjust the level of damping. Sliding the two plates to this position will provide the maximum damping, and moving the plates to this position will provide the minimum damping. A spring is provided, and it can be attached to the beam at the same position as the damper. This spring, along with added weights, can be constructed to be used as a tuned dynamic vibration absorber. Photonic sensor. The photonic sensor used in this experiment is a device used to measure amplitude of oscillation. By emitting a ray of light and measuring its reflected intensity, the amplitude of oscillation can be determined. The intensity of light is related to the distance between the beam and the sensor. The reflected light received by the sensor is converted into an analog voltage signal. By sending this signal to an oscilloscope, a trace is produced, which is related to the displacement of the beam. The photonic sensor is a nonlinear device that behaves linearly in certain regions, like the CD and EF regions on the calibration curve. The sensor should be operated in region CD for high damping tests, and in the region EF when used for the low damping tests. The photonic sensor is turned on by a control unit attached to the apparatus frame. Stroboscope. In addition to measuring the amplitude of the beam vibration, it is also important to measure the phase difference between the input force and the beam displacement. By shining a strobe light, triggered to flash at the same frequency as the electric motor, at a moving pointer on the unbalanced discs, the phase angle can be read on a stationary protractor. The triggering device for the stroboscope is an electric circuit with a set of contact points. One of these points is fixed to the oscillating beam, and the second to the micrometer screw. If the micrometer is adjusted so that the points just close at the maximum displacement of the beam, the stroboscope will flash at the same instant as this displacement.